Hello everyone. So today we are going to discuss the problem add and search a word. It's a Leetcode problem number 211. Okay. So add and search word. Okay. What you are given is you are given two APIs. The first one is void add word, and here you are given string word, and the second API is boolean search the word, and you are also given the word that you need to search. Okay, now the only thing here is when you are given search, for example, you may also be given the word as like this dot ad. What this means is in the place of dot it could have any character. Okay, so it could be the dot could be replaced with any characters. So for example, suppose you are adding word bad, bad, then you are adding a word dad, dead, and then you are adding a word mad, mad. Okay, so these are all the words that you are adding. So these are all the words that you have added. Now you are going to search the word, so your search query. Okay, so now you are going to search the word. Okay, so now for the search we have a word pad, right? So we don't have any word pad, so this is going to return false. Then the next word is bad. We do have a word bad, so this will return true. And then the another search query is dot ad. This will also return true. Why? Because the dot could be replaced with any character, so we don't care what should be in the place of dot, but a and d are matching. Then the next word is b dot dot, like this. This will also return true because we have a b, the word that is starting with b, and we don't care about what should be in place of dot. Okay, so now here to solve this problem, okay, whenever you see that you want to search a word, search the string, usually those problems, they are the tries problem. Okay, so for this problem we need to use the try. We'll add all the words in the tries and then we're gonna search in the try. Okay, so our approach will look like this. Let's write the approach. So we are going to use what? Tries. We are going to use tries data structure. Okay, then we are going to add word. The add word API will what it will do? It will insert into try. What is the complexity of adding a word into the try? It's O of k, where k is equal to length of word. Okay, so that's the complexity of adding a word into try. If you're not familiar with try, then please watch my other videos on the tries, which has a detailed description of how to implement tries. And then we are going to search the word in try. To search a word in try also, the time complexity is O of k, where k is equal to length of word. Okay, and we have only one constraint, that whenever we are searching in the try and we get a dot, then we need to search all the children's, right? All the children's whenever we get a dot. Okay, so let me make a try. Let's draw a try of whatever the input we have. Okay, so let me draw a try. Okay, so the try always has a root node, so there will be a root node here. So this is a root node. Okay, and then so that's the root node. The try has a root node. Then the first word we are adding is BAD. Okay, so the root node will have a child node B, A, and then we are going to have D. Okay, now the word ends here, so we'll always mark the end of word true. So this means that the word BAD ends here. Then another word we have is D, A, D, and the next word we have is MAD. So that is M, A, and D. Let's mark the end of word, and let's assume we have another word which is cat. C, A, T. Okay, and this is the end of word which is true. Now we are searching for a word P, A, D. Okay, so we'll take a first character P. We'll see, does this root has any child P? No, we have B, D, M, C, but we don't have P, so that's gonna return false. Okay, then the next word we are searching is B, A, D. So we'll see, does this root has a child node B? Yes, it does. Then we'll see, does this node B has a child node A? Yes. Does this node A has a child node D? Yes. And that's the end of the word, I mean the end of our search word, and it's also the end of the word is true, and our search string is also done. So this is going to return true. Okay, the next search is dot A, D. Okay, so now the dot could be any character. So from the root we'll search in all the child, like we have a child root node has a child B, D, M, C. So we'll search all the child that if it has A, the next character is A. Okay, so for the all the children of root, we'll see if they have a A. So all of them have A. B has A, D has A, M has A, and C has A. Then we'll go to the next character. The next character is D. So we'll see which A has D in it. So this 3 A has D in it. BAD, DAD, and MAD. So our search string, as soon as it finds this any first word, it returns true. We don't need to find how many are there or what exactly those words are, so it will return true. The next is B, dot, and dot. Okay, so we'll see, does this root has a child B? Yes. And then it's a dot character, so we are going to search in all the children of B, which is there is only one child. Then again there is one more dot, so we are going to search in all the children of A, and will return all the words. I mean, we are not returning the words, but will return true. So this will also return true. Okay, so this is how we are going to do. So now we already wrote a approach. Now let's implement it. It's very, very simple to implement. Okay, so you are given a public class word dictionary. Okay, and first of all we need to create a node structure for the try node. So we'll do that, public class try node. And as I told you, the try node has a hash map, public hash map. It has a hash map of character and try node, and those are all the those are all the children of the try node. Then to mark the end of the word, we have public end of word. Okay, so that marks the end of the word. And then there is a constructor public try node, and we'll initialize this children is equal to new hash map, and then end of word will be false. And we are done with our try class. Okay, now so we'll take public try node root. So that's the root node, and then we have a constructor of this class, public word dictionary, and in that constructor we are going to initialize our root is equal to new try node. In tries the root is always an empty node. Okay, and then now we are going to implement our APIs. Okay, so the first API is public void add word, and you are given a string word. Okay, so first thing we are going to do is we are going to insert into try node. So we need to grab the root. So try node current is equal to root. Then we are going to iterate through each character of the word and will insert them into the try. So for integer I is equal to 0, I less than word dot length I plus plus. Okay, and the first character is character ch is equal to word dot character at I. We'll see if there is a node, if the root already has a child with that character, then we don't need to create a new one, right? But if it doesn't, then we'll add that child as the children, one of the child of the root node. So try node is equal to current dot children dot get ch, right? If it already has it, right? So if there is already a node, then this will not be equal to null, but if there is not, then this is equal to null. So if we don't have a node, then we are going to create one and add it. Okay, so node is equal to new try node, and then we are going to add that node. Okay, so current dot children dot put chn node. So our node is added, but if there is already a node, then move forward with the next character. Let's update our current. Then current is equal to node, and then let's go with the next character. And at the end, once we are done adding the whole word, current will have the last character, and we'll do current dot end of word is equal to true. Okay, and we are done with this API. Very simple. Now we are going to implement the search. Okay, so public boolean search, and then we have our string word, right? And we'll take a helper here, because when we have a dot, remember we need to search in all the children, right? It's kind of the we need to search for all the children. So we are going to make a recursive call, taking that node, passing that node, and passing that whatever the index of the string that we are searching. Okay, so we are going to use the helper function. Our helper function will take the word. Our index will be pointing to the 0th character, 0th index, so the first character, and then we are also passing the root node, because we are going to start our search from the root node. Okay, so our function will return a boolean, so public boolean search, and then it has a string word, integer index, and try node current. Okay, so first thing what we are going to do, if the index, right, is equal to word dot length, so if the word size is 5, the word length is 5, then the index goes from 0 to 4. But if the index is 5, then that means we are done with our word. So that is the base case, right? The base case is if this index is equal to word dot length, right? That means we are done with the word. We found a match. Okay, so we'll return current dot end of word. It should also be a word. Okay, we found all the characters and everything, but that boolean should be true, which says that it's a word in a dictionary. If not, okay, let's say we are starting with index 0, the first character. So what, we'll take a first character, which is word dot character at that index, and then we are going to search. Okay, so let's say if the character is dot, if the character is equal to dot. Okay, so in case of that, we are going to search all the children. Okay, so we are going to search all children of who? The current node, right? So for map dot entry, it's a hash map, right? So try node child, so it's a children of current, so current dot children dot entry, that this will give you all the children of the current node. We are going to loop through each child and we'll see that whether the next character after dot matches. Okay, so if the next character matches, so we are going to search for the next character. So the word in index plus 1, right, the next character, and the node will be the child node, right? In the we are going to search in the child node, the children of the child node. Okay, so child dot get value, so that closes that and this closes this. Okay, so if that returns true, that means we found the word and we are going to return true. Okay, we are just going to return, we don't need to search further. We found it. Okay, so that if closes, and then this closes the for, and this closes if the character is a dot. But if the character is not dot, okay, let's say we are searching BAD, right? If that's the case, then what we are going to do, we are going to search for B. So try node is equal to in all the child of the root. So we are going to see if there is a character B in it. If we have it, then this node is definitely not equal to null, right? So if node is not equal to null, right, then what we are going to do, we are going to search for the next character. If it's BAD, then we'll search for A. So return search and then word, so it will be at index plus 1, and we're going to pass the node B because we need to search in the child of B, children of B, whether we have a or not. Okay, so that will make that recursive call, and that finishes our if, and then that also finishes our else, and I guess we are also done with the main function. Okay, this one. Okay, so we are done with everything, I guess. Yeah, that's it. Oh wait, so that finishes our if, that is, this is for else, but then before exiting out, we need to return false if none of them return true, then we'll return false. Okay, so that's it for searching, adding and searching a word.